Get ready for a cosmic disaster on a Betelgeuse scale never before seen. Red Colossal. It is sending terrifying signals across space. Astronomers have discovered something profound about this huge object using the James Webb Space Telescope. Brian Cox has issued a very serious warning. Question that keeps lingering. Is there a possibility that we will soon witness a massive supernova explosion that will change the night sky forever? In the vastness of the universe, stars are born, live, and die in astonishing ways. Recently, one star has captured the attention and concern of both astronomers and the general public. It is Betelgeuse, a red supergiant star that stands out in the cosmic constellation of Orion, a large and very old star. Its reddish color and changing brightness have always fascinated me, but more recent events have made people even more interested in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a major event in its history. But what could these changes in Betelgeuse mean? Are we seeing the beginning of a cosmic spectacle on an unimaginably huge scale? Betelgeuse is a stellar giant, 900 times larger than our Sun, something difficult for humans to comprehend. A star so massive that if it were to replace our Sun, its surface would extend past the orbit of Mars, surrounding Venus, Earth, and Mars. This enormous size not only shows how impressive Betelgeuse physically is, but also at what stage of its life cycle it is right now. As a red supergiant, Betelgeuse is nearing the end of its life, expanding and contracting. This phase comes after converting hydrogen to helium at its core. Believed to be between 8 and 8.5 million years old, it's been changing significantly. Over tens of millions of years to become the red giant we see today, it is now in its final stage as a red supergiant. Supergiant stars like Betelgeuse undergo significant changes throughout their lives due to the constant pressures of nuclear fusion and gravity. What makes this stage of Betelgeuse unique? It's its reddish color. Its red hue is due to the fact that its surface is cooler than other stars, like our Sun. While the Sun's surface possesses a temperature of approximately 5,500 Kelvin, the surface of Betelgeuse is about 3,500 Kelvin. Because of this lower temperature, Betelgeuse releases light wavelengths that make it appear red. But this color is more than just how it looks. It tells us something about the physical state of the star and the processes occurring in its huge, gaseous volume. The color of Betelgeuse has changed over time. During the Roman and Chinese eras, Betelgeuse was said to be yellow. About 2,000 years ago, in the 9th century, Arab astronomers were the first to claim that it was red. This change in color throughout human and scientific history has also shown how the star has evolved over time. Another interesting thing about Betelgeuse is that its brightness varies over time. It is a variable star, which means that its brightness rises and falls regularly. This variation has fascinated scientists and skywatchers for hundreds of years. Betelgeuse goes through a brightening cycle of 400 days and a longer cycle lasting 5 years, as Sir John Herschel wrote in 1836 about these cycles. Aboriginal stories may go back even further, however. What really makes Betelgeuse mysterious is not only how its brightness changes, but also how irregular it can be. Unlike many stars that dim and brighten in predictable ways, Betelgeuse sometimes deviates from this pattern, suggesting complicated processes within its enormous structure that are less well known. Recently, astronomers and stargazers around the world were surprised to see Betelgeuse's appearance change dramatically and unexpectedly. This is known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the brightest stars in the night sky and a prominent feature of the constellation Orion, began to dim in a mysterious way. The star was fading at a rate of 0.01 magnitude per day on average. By February 2020, Betelgeuse was at its faintest, normally. Visible to the naked eye even in areas where there is a lot of light pollution, it had become much fainter, and onlookers could tell the difference. However, the paradox of time complicates observing Betelgeuse because it takes so long for the star's light to reach us. When we look at Betelgeuse, we see it as it was almost 654 years ago, because it is about 654 light-years away. This time lag makes it difficult to predict and monitor rapid changes in its behavior. The Betelgeuse dimming event was a reminder of how complicated it is to observe the night sky in real time, and how little we understand about this large and bizarre universe of space and time. Dupree, Deputy Director of the Harvard-Smithsonian Center for Astrophysics, and her group of astronomers and physicists took a close look at Betelgeuse's dramatic events as part of a 3-year study to track changes in the star's outer atmosphere. By utilizing these Hubble observations, they provided new insights into how a variable star like Betelgeuse works. Variable stars regularly expand and contract, causing changes in their brightness. The researchers were able to observe the star's surface layers heated in part by swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Studies of Hubble spectra, taken at different times in 2019 and 2020, helped determine how fast things were moving in Betelgeuse's upper atmosphere. They found that material was moving from the star's surface into its atmosphere at about 200,000 miles per hour, eventually reaching millions of miles away from Betelgeuse. This movement of material contributed to the formation of a dust cloud that made the star appear less bright for 3 months. Dupree and her team thought that about twice as much material from Betelgeuse's southern hemisphere had been ejected. This mass loss was remarkable because it occurred at a much faster rate than expected. The astronomers wondered whether this event might be a sign of an upcoming supernova explosion. Given how large the mass release's magnitude and the star's dimness became at 654 light-years from Earth, Betelgeuse's behavior remains a mystery. Such an explosion would be visible from Earth and would give people a rare chance to see a supernova up close. But the question remains, is this a sign that a supernova is about to occur, or is it simply a one-time event in the long and complicated life of Betelgeuse? Several theories have been proposed to explain this rapid change. Let me know what you think in the comments box. If you like, make sure to like and subscribe to the video, and also turn on the notification bell to receive any content like this. Thank you so much for watching the video, and I'll see you in the next one.